Hi guys, for number 1, I will work out the work for that later, but just so you have what I have for my answers, I have A, x bar equals the sum of x over n, which allowed me to have 9.5. And then over here, we see we have B. After creating that giant chart, I ended up with S is approximately 7.1. Again, on your quiz or test tomorrow, I'd expect you to make the whole chart. And then I also ended up with that E, which is what I was looking for here, my error of ZC S over square root of n, which is equal to 1.645 times 7.1 all over the square root of 32, which is approximately 2.1. Over here for number 2, it says construct the indicated confidence interval for the population mean of a confidence level of 95% and x of, should be x bar, it just was hard for me to put that in, so tomorrow on your test will be the same way, of 10.1, a standard deviation of 0.277 and an n of 100. So we're back at that formula of x bar plus or minus ZC S over square root of n. So we're creating that confidence interval with adding that error. You see that ends up being 10.3 plus or minus. You go back to the back of the book. Remember, this is a two-tailed test for confidence intervals. So the one associated with 95% is that 1.96 times that 0.277 all over the square root of 100. With that, you see that you end up with 10.3 plus or minus 0.054, which gives me an interval 10.2 to 10.4. Okay, so now we're on to number 3. For number 3, we're determining the minimum sample size to estimate mu. Use the results from question number 1. Now suppose that you want a 98% confidence with a maximum error of 0.5 mile. How many people would be needed for the survey? So we have to use that formula. So you have to go back to that section. You can find n equals my z-score, so my critical value, times sigma all over my error squared. This might be a formula I'd want starred on my note sheet. We end up with 2.33 times 7.098 all over my error of 0.5 quantity squared. What you're going to do is put that into your calculator, and you see that you end up with something like 1094.06. Remember, we always round up even if it's 600ths of a person, which gives us 1,900, still can't handle, 1,095 people. I'll try to do better on the next one. So for section 6.2, which is where we're at right now, we're going to find the critical value, TC, for the given confidence level and sample size n. So we see that we have a C of 98 and we have an N of 14. So you are going to look for your alpha equals 0.98. And we have a degrees of freedom, which is 15 minus 1, which is 14. You're going to go in the back of your book, and you're going to find that your T is going to be something like 2.624 for your critical value. Number 5, again, we're doing the margin of error. So this section has the margin of error for TC times S over the square root of n. You have your TC value as 1.753. S is 2.56 all over the square root of 16. You're going to substitute this into your calculator or plug it into your calculator, and you'll end up with 11.2. So your margin of error is 11.2. And then the last one for this page, we see that we are constructing a confidence interval here. This one gives us a pie chart to work with. You have your P hat plus or minus your critical value all over the square root of P hat, Q hat, all over n. So we have to calculate part of this. You see that you have 116, so P hat equals 116 divided by my total of 644. So if you put that in your calculator, you end up with 0.18012, but we'll just use that first part here. And then we're going to substitute that over here, so I end up with 0.18 plus or minus. I go to the back of my book and I find the critical value associated with 0.99. Remember, this is a two-tailed test if you're kind of constructing a confidence interval. So that means that you have 1%, so 0.5% is being spread between the other two, which means that you have 2.575 is the value we're looking for, times the square root of my p hat, which is 0.180, times my q. Remember, that is the complement of p, so it's 1 minus 0.180 all over my n, which is 644 people. My q here, you see that that's 0.82. Once again, you're going to substitute that or plug that into your calculator. You have 1.8 plus or minus 0.039, which allows us to get our interval. I'll move it up in case that you guys can see that little symbol on our page. So I'll write it in red above, and you'll see that you end up with 0.141, 0.219 as our solution. So we're on to number 7, and for number 7, we wish to estimate with 95% confidence within 5% of the true population the proportion of U.S. adults that think they should save more money. When there's no preliminary estimate, remember we have to use P and Q as 0.5. So we're going to go back to using the formula of N equals P hat times Q hat times ZC over the error squared. Well, if we don't have a preliminary estimate, again, you're using that 0.5 because there's 50-50 chance of success and failure. And then you have 1.96. You're using that based on your critical value. Remember, you have to use that alpha. And you know that your confidence level is that 95% all over your error, which is 0.05 squared. We end up with 384.16. And you can't have half of people or 16ths of people. So what you're going to do is you're going to have 385 adults. So the next one is the same scenario, but now you have a preliminary estimate. So our preliminary estimate now says that you found that 63% of U.S. adults think they should be saving more money. Well, that's going to be your p hat. So we're going to use that same formula. So N equals my p hat, which is now 0.63. times my Q. Remember, that's 1 minus P hat, so that's going to be 0.37 all over 1.96 times 0.05 squared, which allows us to have 358.19 or 359 people. So when it says compare your results, all it's looking for is you see that you have the minimum sample size is going to be smaller when you have those preliminary estimates. We need less people when we actually knew what our original proportion was. So I wrote here, minimum sample size is smaller when preliminary estimate is available. And then we're now on to 6.4. So 6.4, this question a couple of you guys asked me about today in class. Find the critical values for the given confidence interval. It is a two-tailed test with your C being 95% and your N being 13. So remember that this goes back to now we are in the chi-squared test. So you have the 1 minus 0.95, and so you have to take that, divide by 2, and then you have 1 plus 0.95, divide by 2. You end up with 0.975 here. You end up with 0.025 up here. And then you go to the back of the book. Remember, this is area to the right on this table. unlike the other ones, and you end up with your values of and over here you end up with, so hopefully you had enough time to put those into your calculator and look in the back of the book. So again, number 9 is long. It's when you're going to need a table for. So I'm not going to construct that right now. I'll come back to it when I have more time. I just want to get the majority of the video done. And so now we're on 7.1. So here, use the given information, use the given claim to state the null hypothesis and alternative hypothesis. Identify which one is the claim. So it tells you which one is the claim, and this one has the equal to sign. So which one goes with that? Is it your null or alternative hypothesis? So we see that we have HO and HA. Up here we know that mu is less than or equal to, since it has that equal to symbol, means it has to go through null hypothesis. Down here, it's going to be the complement to that. We know the claim is what it gave us, so claim is your null hypothesis in this case. Your second one, you see that P is less than 0.205. So that does not have an equal to sign with it, so that means that that is your alternative hypothesis, which means up here we end up with P is greater than or equal to 0.0205, and your claim is what's given, so that's your alternative hypothesis. And then your last one, you have your null hypothesis, your alternative hypothesis, and you see that you have your P is greater than or equal to 0.78 given, so that's your claim, has the equals to sign, tells you that's your null hypothesis. The complement is going to be your alternative hypothesis. On number 11, I will move it down so that we can see the full thing. So here, a researcher center claims or believes that the proportion of college students occasionally or frequently come late to class is 63%. State the null and alternative hypothesis. So our first step here, HO, HA. So the proportion is 63%. So that's going to be my claim. And my alternative hypothesis is going to be the complement to that. So that's P does not equal 0.63. So our type 1 error. So you're going to have to give me a second as I write all of this out. This goes along with that table. So type 1 error will occur if, I'll actually write this out and then I'll hit play again, so give me 1 second. Okay, so thank you for letting me pause the video so I had a chance to write this out. So you see a type 1 error occurs or will occur if the null hypothesis is rejected when the actual proportion of college students that occasionally or frequently come late to class is 0.63. The type 2 error is not rejecting when the null hypothesis, when the actual proportion of college students that occasionally or frequently come to class late is 0.63. Okay, so we need to determine if this is right, left, or two-tailed. Well, since it's not equal to, we see that this is a two-tailed test. And we see this because it's the not equal to sign. And then we want to know how we should interpret the results if it rejects the null hypothesis. So based on the fact that our claim is our null hypothesis, we would say there is enough evidence to reject the claim. There is enough evidence to reject the claim. So again, this goes back to the chart that we filled out, and it has the different scenarios. So if your claim was HO or HA, and then if you reject or fail to reject the null hypothesis, what you should write, you can have that on your test tomorrow. And then there is not enough evidence to reject the claim.